Okay, so I said we had a couple of demonstrations which Terry's going to run us through now. So I've got a second camera here so you can see what's going on the bench, and obviously the main camera as well. So Terry.
Yeah, okay. As we said earlier on, Marconi used spark transmitters to transmit. Now, most people would probably never have heard of a spark transmitter, would never have been near one. Basically, he used an induction coil, put a low voltage in, stepped up to a high voltage, generated a spark, and that spark generated the radio signal. It was very wide band, it wasn't tuned, and it would cause a lot of interference to other radio systems, which is why spark transmitters are not permitted these days. They've been banned since 1938. I think they were allowed in lifeboat transmitters up to that time, but nowadays nobody would ever consider using a spark transmitter. Anyway, we have here a very low power spark transmitter, so we're not going to generate any interference, which you probably recognise as an igniter from a gas cooker. A little spark here, when you press the buttons, a piezo device in it, and it generates a spark. Simple as that. We've made it into a radio transmitter by adding this high gain aerial here. Okay, so that is our demonstration transmitter. And the receiver is equally simple. Oh, sorry, I'm wrong camera. Here we have what's called a coherer. This was developed in the late about 1890 by a Frenchman called Brantley. He used it for detecting lightning. But it consists of a tube, a glass tube. This is actually a bit of a biro, so it's a plastic one. And it has in it some metal filings. You can use nickel or iron filings. The contact at each end. And under normal circumstances, it doesn't conduct. So we have a meter here with a circuit of the battery into the meter. And when this conducts, you're seeing a current flow on there, and obviously a receiving aerial. So that is the simplest possible receiver, and it's the sort of thing that Marconi used in his early experiments. And it was actually, one was available in Glace Bay in Canada when he did the transmission across the Atlantic. Now, with a favourable wind, if I press this button, the meter moves over. So we've now got current flow. Do that again. Okay, so we're now showing current flow. Now, the problem with this is that once the coherer it is called cohered, and actually all the filings have clumped together, the current will continue to flow. So in order to reset it, to get the next character, dot or dash, you have to tap it. So what they used to do is they'd have the arrangement like a bell, and when the current flows, like that, the clangor of the bell came over, hit the coherer, and reset it. So in this way, you could send Morse very slowly. And it's absolutely amazing that he actually managed to use this across the Atlantic. The next development that Marconi company developed was a thing called the magnetic recorder. And we have an example of one of those here. This is quite a bizarre instrument, but it did work very well in those days, and it had several advantages over this. You didn't have to keep resetting it, and it was more sensitive. So what we've got here is a loop of soft iron wire, a bit like a tape recorder, but it's just a single loop, and it's driven by a clockwork motor, which would drive it continuously around. There are magnets here which bias the wire so that it has a magnetic field or a magnetic charge in a constant direction. So it's always in the same direction. And here we have a pickup coil which is connected to a pair of headphones. Now, if you pass a magnet through a coil, you will generate a voltage which you'll hear in the headphones. But that only happens if the field changes. If it's a constant field, you hear nothing in the headphones. As soon as it changes, you'll get a click in the headphones. So what is done, the aerial is connected to another coil in the same position. Now, when the radio signal comes in, or the lightning, or whatever it is, comes in, it will demagnetize the wire in a certain position there, and as it goes through the pickup coil, you hear a click. So it's a very simple receiver. There's no gain. There's no power needed, but it was continuous, and you didn't have to do a reset, and you could actually send much faster with it. And this is called a magnetic detector. It used to be called Maggie's Marconi magnetic detector, and it's a replica of one that was used on the Titanic. The thing about all these detectors is there is no gain available. There were no valves, transistors, integrated circuits available at the time. So anything you hear in the headphones or see on the meter is power coming from the transmitter. They weren't able to amplify the signal, so that the tiny bit of signal they heard in Canada came from Poldhu. It wasn't until Fleming invented the valve and allowed the signal to be amplified that they could move away from needing so much power in the transmitters. And obviously these days, in the amateur radio world, we use perhaps 100 watts and we're able to talk all over the world, thanks to having gain in the receivers.
So there we go. There's a couple of demonstrations of the sorts of things you can see here. Absolutely brilliant site. Well worth coming and having a look. Been a brilliant day. Big thank you to Terry and to Callum as well, who organised this for me. And I just want to make the point, we're filming this on a Saturday, and this place is normally closed to the public on the Saturday, and they've opened it especially for me to come down here and spend a bit of time, have a look around, and also to operate their radio station, their club station as well. So massive thank you.
Well, yeah, do come and visit us. We're down on the Lizard in Cornwall, which is the home of communications. We've got Goonhilly, we've got cables, all sorts of things down here. If you're interested in radio, the Lizard is the place to come to. Come and visit us here on a Wednesday or a Sunday, and we'll happily talk for hours about radio.